another type of horizontal asymptote I want to mention in this video is called a horizontal asymptote. And horizontal asymptote is defined by looking at the highest exponent of the numerator and the denominator, as well as the leading coefficient of the polynomial on the top and the bottom of rational function. Okay, so on the second part is horizontal asymptote. Let me rewrite the general form of rational function over here. So we have f of x equal to p of x over q of x, right? And p, q is they are polynomial, and because they are polynomial, I can write it as a sub n x to the n plus dot 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 dot, right? And over here we have b sub n x to the m plus dot 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 dot. Okay, so how do we know how we're gonna find horizontal asymptote? By look at the n and m is the highest exponent and highest exponent of the q of x, as well as the leading coefficient of p and q of x, which is in this case is a sub n and b sub n. So we can have the rule. We have the rule. It's called horizontal asymptote rule. Okay. These rules help you find the equation of horizontal asymptote. Well, because it's horizontal line, right? So the equation will be something like y equal to a number. Okay. So we have to compare the n and m, the exponent of the highest exponent of polynomial p and q. If n equal m, okay, if n equal m, then the horizontal asymptote will be y equal to a sub n over b sub n. Okay. If n less than m, then the horizontal asymptote will be y equal to 0, which is in this case, which is the x-axis. Okay. And if n is greater than m, then we don't have any horizontal asymptote. No horizontal asymptote. We have another type of asymptote, which is I'm going to talk about later. We call it slanted asymptote. I'm going to talk about this. But before I talk about slanted asymptote, I want to go through some examples so that you can understand better. Okay. For example, I have a rational function that looks like this. F of x equal to ax squared plus 9x minus 5 over 2x squared plus 1. So what is the highest exponent of each polynomial here? I can see the highest exponent here is 2, right? And the highest exponent here is also 2. So n equal m. And because it's n equals m, the horizontal asymptote will be what? Horizontal asymptote will be y equal to, right? N equal m, right? N equal m, because n equal m equal 2, n equal m equal 2. So horizontal will be with a sub n over b sub n. A sub n is 8 over 2, the leading coefficient. Okay, the coefficient that attached to the highest exponent of each of the term of the polynomial. So it is will be 4. Okay. So how about if I have a function, rational function that looks like this? F of x is equal to ax squared plus 1 over x4 plus 1. So I have n equal 2 less than m equal 4, right? If it's less than, then the horizontal asymptote will be y equal 0. Okay, because n is 2 and m is 4, is less than. Okay, and you see that you just need to look at the leading coefficient and the highest exponent to define the horizontal asymptote equation. Okay, a third type of asymptote, when we have the exponent on the top is greater than the exponent at the bottom, is called slanted asymptote. Okay, slanted asymptote when n is greater than m. Okay, and in order to find slanted asymptote, you need to use the division. Okay, you can do a long division or you can do a syntactic division. It's up to you. So you have to use division to find slanted asymptote. Let's see something. How about this? What if I have fx equal to x squared plus 1 over x minus 1. So you see over here n is 2, right? It's greater than m is 1. So the highest exponent on the top is greater than the highest exponent at the bottom. So we know that there's slanted asymptote. There's no horizontal asymptote. But we also have vertical asymptote over here. Again, vertical asymptote will be x equal to 1. I already talked about vertical asymptote in the previous video. Okay. So in order to find slanted asymptote, we're going to set up the division. So most of the time, I use the long division to find the asymptote. Okay, so I'm going to set up the long division. So x minus 1 here. So I have x squared plus 0x, because we don't have, you see we're missing the first degree term, plus 1. X going to x squared give you x. So x minus x squared minus x, do subtraction, 0. X drop number 1 down. X plus 1. It'll give you what? X divided by x give you 1, right? 1 minus x minus 1 minus 1. So the remainder is 2. The remainder is 2. So where is slanted asymptote? The slanted asymptote is the quotient. So quotient is slanted asymptote. Whatever after you do division, you have a quotient, that is slanted asymptote. Okay. So, and because this asymptote is a line, so we have to write it as the equation. So the slanted asymptote will be y equal to x plus 1. There you go. Okay. So it's very easy. You know, all you have to do is you do a long division. Okay. So you must be able to do long division in order to find slanted asymptote, and in order to define the slant, they have slanted asymptote. And now you look at the highest exponent of the top and the bottom. Okay. So to continue with this lecture, I want to go through an example, and in this example, I want to I want to find different type of asymptote. I want to find the domain and range, because the asymptote will help you to find the domain and range. Okay, you know that the asymptote is where the function is not crossover. So this is where the function is not defined. Okay, so it will help you to find domain and range. A vertical asymptote will help you to find the domain, and horizontal asymptote will help you to find the range. Because horizontal, if you can find horizontal asymptote, you can find where the function, the range is not defined. Okay, so let's do another example, more general, something like that cover all the concepts we learned so far in the previous video and in this video. Okay, let's see. Let's see, I can find an example like that or not. Okay. Okay. Example. I have f of x equal to 2x squared plus 9x plus 4 over x plus 3. So I want to find all the asymptotes as possible. Okay, find all asymptotes as possible. I want to find the domain and range. Okay. Then I want to find x and y intercept 1. Okay, for x and y intercept 1 you already learned. Okay, to find those one in for the previous function. But well, for x and y intercept, the concept is the same. You know, you just replace x with 0, replace fx with 0, and you solve for that. All right, answer. Let me erase this too. Okay, so let me find all the asymptotes. We know that on the top and the bottom, so n on the top, n equal 2, right? The highest exponent 2, the highest exponent over here is 1, n is greater than m equal 1. So we have slanted asymptote, and we don't have horizontal. So we have slanted asymptote. Okay. We also have vertical asymptote because we have the denominator. We also have vertical asymptote. As long as you have denominator, you have vertical asymptote. This be the value that make the function undefined. Okay. Alright. So vertical asymptote will be x plus 3 equals 0. So x equal to -3. We already learned how to do this. For slanted, because the top is bigger than the bottom, we have to do division. So x plus 3, set up division, 2x squared plus 9x plus 4. So x going to 2x give you 2x squared plus 6x minus that give you 3x plus 4. X going to 3x plus 3. 3x, 3 times 3 is 9, subtract that, give you -5. So slanted asymptote will be y equal to 2x plus 3. So this is slanted. Okay. We don't have horizontal again because the exponent is greater than the exponent at the bottom, we don't have horizontal asymptote. So we have only two different types of asymptote, vertical asymptote and slanted asymptote. Okay. B, domain range. For the domain, we look at vertical because asymptote because x is different from 3, right? Because if x is different from -3. Because if x equal to -3, -3 plus 3 is 0. We're not allowed to have 0. So the domain will be everything else except for -3. How about range? Okay, because we don't have horizontal asymptote. We don't have horizontal asymptote, so the range. Do we have horizontal asymptote? Let me see. Yep. Because we don't have horizontal asymptote, then we don't have the range. The range could be negative infinity to positive infinity. We don't have any point where the range is undefined. Okay. So the range from negative infinity to positive infinity. Okay. Let's see. Okay. X-intercept. So in order to find X-intercept, point, you plug fx equals 0, so you have 0 here. This time 0 is 0, so you have 2x squared plus 9x plus 4. And this is quadratic. Let's see if we can factor this or not. So you have 2x here, x here, right? You have plus 1, 4 plus 1, right? So you have 2x intercept point will be x equal to -half. And x equal to -4, and because it's the point, so you have to put in order pair form, -1/2, comma 0, and -4, comma 0. So we have two intercept points. For y-intercept, you replace x with 0. Y-intercept point. Okay. Intercept. Okay. You replace x with 0, so you have 0, 0, 0, so your answer is 4/3. So your intercept will be 0, 4/3. Okay? That's all. That's all. This concept you already learned. I think you guys all know how to do this. Domain and range, you look at the bottom. The range, because we don't have horizontal, so the range will be from negative infinity to a positive infinity. Okay? For this concept, I'm not gonna ask you to graph or anything on the test because you have calculator already. I don't think there's no reason to learn graphing because you already have calculator. But on the test, I'm gonna ask you some question that's similar to this. Okay, so make sure you understand it because so far I have not seen a lot of discussion question on the discussion board. I don't see you guys ask any questions, so I don't know if you guys really understand it. So please, if you guys have any question, please post your question on the discuss board. Okay, so I want to see how you guys learning. I know that because this is the online version, it's very hard for me to check you guys really understand the material or not. So the only way you guys can help each other and collaborate, and we're gonna help each other online through discussion board. Okay, so do not hesitate asking me any question on discuss board. We're gonna discuss and try to find answer for you. Alright, then I'll see you the next time in the next video. Thank you. Bye bye.